I'm in Minitab looking at the hand group strength dataset, and we're going to look at analysis of variance. With the two sample t-test last week, we had a look to see if there was a difference in hand group strength between the two genders, and that's all the t-test can cope with is two groups. If we want to look at arthritis, which I've got here in C7, there are four groups and we need to use analysis of variance in order to see if there's a difference in those four groups. Now, it's not particularly convenient to look at the numbers 1, 2, 3 and 4 because it doesn't really tell us what's going on. So if I bring up that README file that came with the data set, we can see that arthritis is self-reported severity of arthritis in the hands based on the question, do you suffer from arthritis in the hands? And the responses are yes severely, yes mildly, yes very slightly, or no not at all, coded from 1 to 4. So what we would like to do is code our data set so we can see the levels of arthritis when we do our analysis. So let's go into data code, and we want to go from a numeric variable to a text variable because we want to put the words in there. So that's this option here. Now we want to go from arthritis and we're going to store it in, you can call this whatever you like, arthritis 2. And we had 4 levels, 1, 2, 3 and 4. 1 was severe, 2 was mild, 3 was slight, maybe we'll put the LYs on the end, mildly, slightly, severely. This is up to you how you code it. It's so you can read it on the graphs. And then 4 was not at all. Now I'm not sure how it's going to cope with those spaces. We'll see if it can do it, and if it can't, we'll come back and change that. Okay. Oh, it's done it okay. Sometimes you need to watch having spaces in your labels. It can cause issues. We'll see how it goes, and if it causes an issue, then we'll come back and change it. So now I've got arthritis coded. Let's have a look at what's going on with these groups. So we'll go to graph, Boxplot with groups. Okay. Average hand grip strength, so that's left over from last week. We're going to take out the sex and add in arthritis. And we're using arthritis 2 because this is the one that we've coded with the labels. Okay. Alright, so it hasn't had a problem with the spaces in that label, so that's good. So what we've got is, this box plot looks, I feel like, because I just looked at this data set in SPSS, I know that there is an observation up here. Let me just check. It's observation 28 was flagged in SPSS as an outlier, 34, and he's not showing up on this. Oh, he is. Okay. I'll tell you what the problem is. The problem is that it has not drawn these boxes in order. It's gone from mildly to not at all to severely to slightly. I'm just going to pause for a second and see if I can work out how to make it draw them in order. Okay, I've had a look. I seem to remember from the last time I used Minitab, which has been a little while, that it's actually quite difficult to make it order these categories in the way that you want. So there's a couple of things that we can do. It's trying to go alphabetically, if you could see that along the bottom here. So something that we can do is we could either use the labels from the original column and then actually just manually go in here and click these, or we can keep the numbers with the labels and hopefully it will then put them in order. So let's go back and just recode these. It shouldn't take long because we've already got the codes up here. So I just want to put 1, 2, 3 and 4, and hopefully it will then draw them in order. So let's delete that. graph, box plot with groups. Okay. Now everything is going to stay the same, it's just I have changed the labels inside arthritis 2. Alright, that's better. So now I can see, this is the observation I was looking for because I knew it was there. So it looks like it's possible there's a trend of, as the arthritis decreases, the average hand grip strength may be increasing. But because we have this extreme observation here for the one person, number 28, who had severe arthritis but was also very strong, it may be that there's no difference between these groups. So to do that test, we'll go to Stat ANOVA, and you'll see here there's loads of options for ANOVA. Let's just stick with our simple one-way analysis of variance. Our response is hand grip strength. Our factor is the explanatory variable, and this is the one that should be categorical. So this is arthritis. Let's use arthritis 2 just so we get the labels with it. Now we've got here one-way multiple comparisons. So what happens with the analysis of variance is that it does the test to see H0 is that there is no difference between the groups. If we find evidence against that, that means one of the groups is different from the others, but it doesn't actually tell us which group is different. So with the two-sample t-test, when you've only got two groups, if you find that the groups are different, then obviously one group is different from the other. If you've got more than two groups, it could be that one of the groups is different from, say, the other three. It could be that two of the groups are different from the other two groups, but they're not different from each other, and there's all sorts of combinations in between, depending on how many groups you've got. So the idea of the analysis of variance is that you look first to see if there is a significant difference, and if there is, you would need to do what we call post hoc multiple comparisons. And post hoc means that you do it after the analysis, and the multiple comparisons means that you're comparing each group with each other. Now let's just have a look at the two keys multiple comparisons, and the error rate, we'll just leave this at 5. Okay, graphs. Just leave the graphs for the moment and click OK. So the null hypothesis for the analysis of variance is that the mean for each group is the same. We have a very high p-value here, and that's telling us that we have no evidence against this null hypothesis. So we have no reason to go looking to see if one group is different from the other groups. If one group was different from the others, then we could look through here these multiple comparisons. I'll do this in a separate video to see which group is different. However, it's probably simpler, although it may not be completely as accurate. It's probably easier just to do a graph of the means with the confidence intervals. So we'll do a 1Y with groups. We want to have a look at hand grip strength over arthritis. And now we can see, instead of all the data, which is what we can see on the box plot, we can see what's happening with our means and our confidence interval. And you can see that there, although it looks like there's a bit of a trend going up, that you're stronger without arthritis, because we've got this one outlier in group 1 who is very, very strong, we've got a really wide confidence interval just because there's a huge amount of variation in that group. And this is completely overwhelming the rest of the data. And you can see actually that these confidence intervals all completely overlap as well. So it doesn't look like there's a significant difference here. Now what we can do is have a look at taking out the unusual observation and just see how much that is affecting the analysis. Now this doesn't mean that you should go through and delete things that are messing up your analysis, but you can go and have a look and see how much it's impacting the analysis. So the unusual observation, if I hover over it here, it's popping up on the other screen. When you do this in yours, you should be able to see the pop-up, and it says that it's in row 28. So it's this one here. Okay. In SPSS, it's easy to, you can do what's called selecting cases, where you can ignore some or more of the data points while you see what effect they're having. I can't remember how to do this in Minitab, and I'm wondering if it actually doesn't do it the same way. So what we might do is just temporarily delete it, and then we can add it back in again. So we can just delete a row. If you start deleting and copying, you really should make a clean copy of your data set first, just in case you lose something and can't get it back. Columns for which to delete these rows. Well, let's just choose all the columns. And now row 28 is gone. Now, or we probably could have just taken him out. So let's run the analysis again and just see what happens. So if we do the graph again with the interval plot, you can see that without that outlier, the mean hand grip strength for the severely arthritic does seem to look lower. However, we're still getting this enormous overlap of the confidence intervals, so it's unlikely that this will be significant, but the significance will have changed. So if we go back up here to remind ourselves what happens before, we had a really, really high p-value of 0.54. If we run the analysis again, stat, ANOVA, and one way, and just leave everything else the same, we can see that the p-value has dropped. It's now 0.14, but that's still not significant. So what we can see is that the one person who was severely arthritic but also very strong was having quite an influence on the confidence interval for the average hand grip strength for the severely arthritic. However, even without him in, there is still no significant difference between the hand grip strength for the different levels of arthritis. So the question is, have we proven that there is no effect of arthritis on hand grip strength? And the answer would be no, we haven't. We just don't really have any evidence for it in this data set. So it's possible that there is an effect of arthritis on hand grip strength, but we can't pick it up. So that would mean that we need to either design a better study really targeted at looking at that question, and that might mean measuring arthritis in a different way. So here this was self-reported arthritis. Perhaps we would want a clinician to come in and rate the arthritis. Perhaps we would want to look at arthritis on more of a continuous scale, because if there's a trend upwards, it's possible a regression might be effective at detecting the relationship. And we also would probably want to sample more people, so they had a relatively small sample size in this. So from this data set, we have no evidence that there is a difference in average hand grip strength over the different levels of arthritis. However, that doesn't mean there isn't a difference, it just means we couldn't pick it up. And so this is where in the discussion of your paper you might say future research could focus on this question and looking to see more specifically if there's a difference in hand grip strength for different levels of arthritis.